Hi everyone, welcome to Ms. Sawagid's math class. Today we will build on what we learned before about linear functions. For today's lesson, linear functions are written in slope-intercept form, and by the way, this is not the only form linear function is written. We can write it in different forms, but for today's lesson, we will focus on the slope-intercept form, which is y equal mx plus b. M is the slope or the rate of change, and b is the y-intercept or the initial value. Now let's review what we learned about the different names for the x value and the y value by filling out this table. The first one, which everybody knows, the coordinate pair x and y. The x values are on the x-axis and the y values are on the y-axis. Different names for the x value and the y value. Independent is the x value, dependent are the y values. Domain is the x value, and range is the y value. Input is the x value, and output is the y value. Now let's talk about standard notation. That's something new. The word notation means you're taking notes, you're writing notes. So how do you write the x value as a standard notation? It's just the letter x. And the y value is just the letter y. For today's lesson, we will talk about something called function notation. Function notation, how do you write the x value and the y value as a function notation? The x value will stay as x, but the y values will be f in parentheses x. And that's today's lesson, which we will be discussing soon. So what is a function notation? It's just another name for y. Just like the y is the dependent, the range, the output, it's also the function notation or f of x. How can you use function notation to represent a function now? It's f in parentheses x. It's read as f of x. So when you write the equation, which we talked about at the beginning of the lesson, y equal mx plus b, the slope-intercept form. Now write, instead of y, write f of x equal mx plus b. This is the standard notation, and this one is the function notation. Watch how the y is replaced by f of x. Nothing on the right side of the equation have changed. So here's the equation in function notation. F of x equal mx plus b. Remember the table where you have all the different names for the x values and all the different names for the y values. Watch how we said it's at the dependent, range, output, y, and it is the f of x. So f of x is the y value or the output when you replace x with any value. Now let's practice evaluating a function. Here are three different functions. Watch how we wrote f of x, g of x, and b of x. So you don't have to write f to represent a function. You can write any letter, as you can see. So evaluate the function when x equal -2, which means I'm trying to find what the output is. I'm trying to find what the range is, or I'm trying to find what b of x is, or g of x, or f of x, which is the y value. Let's start with the far right. Substitute x with -2 and find the output. Every time you see x, replace it with -2. So b in parentheses -2 equals 18 minus 0.5 in parentheses -2 because I'm replacing x with -2. I want you to watch the difference between b and the parentheses -2 and 0.5 parentheses -2. The b of -2, that's not multiplication. I'm not trying to multiply b times -2. I'm just naming what the function is or the output is when the input is -2. But when you have 0.5 times in parentheses -2, that's multiplication. So remember, the naming of the function is different than multiplying when you use parentheses. So now keep bringing b of -2 because we're not multiplying. This is just the name of the output when the input is -2 equals 18. 0.5 times -2 is -1. Keep it in parentheses and bring the minus down. So b of -2 equals 19 because subtracting and negative is adding. 18 plus 1 is 19. So now how do I write it as an ordered pair? It's x and b of x, or the y. And you write it as -2 and 19. Now the second one, g of x equals 3x. Substitute x with -2. So I'm trying to find the y, or the g of -2. When x equal -2, replace x with -2 3 times, in parentheses, -2. Bring the g of -2 down, equal 3 times -2 is -6. How do you write that as an ordered pair? I need x and y. X is -2, and the y is the g of x when x equals -2, so it's -6. The last one, f of x equals x plus 6. Substitute x with -2. Again, f of -2, that does not mean multiplication. I'm just naming the function when the input is -2. Equal, substitute x with -2 plus 6, and -2 plus 6 equal 4. So how do you write that as an ordered pair? It is x and f of x. X is -2, and the f of x, or the y, or the output, is 4. Now we will interpret function notation. Look at this example. Let f of t be the outside temperature in Fahrenheit, t hours after 6 a.m. Explain the meaning of each statement. Explain means interpret. So the first one, f of 0 equals 58. If I were you, I would write it as an ordered pair with t and f of t. T is the time after 6 a.m. and f of t is the temperature at that time. Since the time is 0, that means right now, which is 6 a.m., the temperature will be 58. So the temperature at 6 a.m. is 58 Fahrenheit degrees. Now, B is f of 6 equal n. The output is n. The input is 6 hours after 6 a.m. So write it as in ordered pair, t and f of t. 6 hours after, that would be 12 o'clock, and n is the temperature. I don't know what it is. So the temperature at 12 o'clock noon equals 2 n Fahrenheit, which I don't know what it is. Now, f of 3 less than f of 9. F of 3 is the temperature 3 hours after 6 a.m. and f of 9 is the temperature 9 hours after 6 a.m. So the temperature at 9 a.m., which is 3 hours after 6 a.m., is less than the temperature at 3 p.m., which is 9 hours after 6 a.m. Now we need to solve for the independent variable for this equation. Do you remember in the table, independent variable is the value of x? So write the equation. Find the value of x for which h of x equals -7. So they give you the output. They give you h of x. What does it equal to? And it equals to -7. So write the equation. Substitute the value of h of x with -7. Rewrite the equation and substitute it with -7. And now we need to isolate x. So I need to get rid of everything on the same side as the x, which is the 53 and the 2/3. Since 53 is free, I will get rid of it first. And the addition property of equality states if you add on both sides, you keep the equation balanced. So add 53 to both sides, you end up with 46 equal 2/3 x. Now, how do I get rid of the coefficient, which is a fraction in this case, 2/3? You multiply both sides by the reciprocal, and the reciprocal means flip the fraction. So multiply both sides by 3/2, 3/2. 3 divided by 3 is 1, 2 divided by 2 is 1, you end up with x equal, now multiply 3 times 46, which is 138, divided by 2. Simplify that, you get x equal 69. What does that mean? It means when x equals 69, h of x equals -7. When the input is 69, the output will be -7. How can we graph linear function written in function notation? Here's an example. Graph f of x equal to x plus 5. First of all, make a table. that has the input x and the output f of x. I'm trying to find the value of f of x, or the output, when the input is -1, 0, and 1. I will show you the first one, and the rest is the same. Replace x with -1, so I'm trying to find the f of -1 equal 2 times -1 plus 5, because x equal -1. Bring f of -1 down, or the f of x, equals 2 times -1 is -2 plus 5 equals 3. So the f of x when x equals -1 equals 3. Put that in the table. Same thing with 0. I need 2 times 0 is 0 plus 5, so the f of x is 5. 2 times 1 is 2 plus 5 equals 7, so the f of x equals 7. To graph it, you can write the ordered pair x and f of x, or plot them and then draw a line through them. Now let's solve real life problem. The graph, and here's the graph about the helicopter. The graph shows the number of miles a helicopter is from its destination after X hours on its first flight. So this is the first flight. On its second flight, the helicopter travels 50 miles farther and increases its speed by 25 miles per hour. The function f of x equal 350 minus 125x represents the second flight, where f of x is the number of miles the helicopter is from its destination after X hours. Which flight takes less time? Explain. How can we solve or answer that question? The first flight is on the graph. The second flight is an equation. So write that equation. If I were you, I would make a table and graph it, just like we did with the other example. Input, output, x is the input, and the f of x is the output. Use the equation. I already had it done for you. Substitute the values of x to find the values of y, or the f of x, because f of x is the y. Now, once you finish the table and you got those coordinates, graph them. So I graphed the second flight, where y is the distance and time is the hours. Look at the graph and watch how the first flight, it took 3 hours to reach the destination. Second flight took less than 3 hours to reach the destination. So looking at the graph, the second flight takes less than 3 hours. What if you wanted to know exactly how long does it take to reach the destination? Use the equation for the second flight, because I know for a fact the first flight takes 3 hours. So all I need to know is the second flight. Second flight, f of x equals 350 minus 125x. To reach the destination, that means the y value is 0. So f of x equal 0. So replace f of x with 0 and find the x, or how many hours. 0 equals 350 minus 125x. Now the subtraction property of equality, subtract 350 on both sides. You end up with negative 350 equals negative 125x. Negative 125 is a coefficient, that's not a subtraction. You multiplying the coefficient to negative 125 times x. So the inverse operation would be division property of equality. So divide by negative 125 on both sides. You end up with x equal 2.8. So it takes 2.8 hours for the second flight to land or reach its destination. And that's how you know exactly, by using the equation, or you can estimate using the graph. That's it for today's lesson. You guys have a great day.